So what we're going to do is design the coat hook. To do this, what we want to do is I have the dimensions out on the board. For those online, it's going to be shown on a PDF. But we're going to do with option A, which is a 3-gauge wire. The thickness is going to be 0.2437. That's the thickness of the wire. One thing you gotta learn is that sheet metal is a different thickness than wire gauge. Even though they're both gauges, it's a different thickness. So keep that in mind for future reference, if you like. If not, it's up to you. Basically, what we want to do is design a 72-inch high by 17-inch wide coat hook. So start with we'll start using the rectangle command first. Create an outline of our size of what we want to work with. Man, I can't talk today. So rectangle, D for diameter. D for dimensions. Actually, you need a point first. Sorry, D for dimensions. 72 by 17. Now it's going to be sideways, but that's all right. I can always rotate. So select the object, rotate. Make sure you have ortho on. If you don't like grid, you can turn off grid. And just try to keep it vertically. So that's the size. Zoom and extend. What we need, it's actually pretty tall. Man, it's tall. So the base is going to be actually 17, which is the bottom of the rectangle. The top is going to be a little bit smaller. We want to make it 15 inches. So what you can do is select that corner, stretch it down 1 inch, and do the same thing from the other side. So this is our max settings for the whole coat hook. Now we use this spline command. So we're going to use the spline. We're going to start from the bottom corner, making sure your ortho's off, otherwise you won't be able to making curvy lines. And we're going to design how the wires should be going to create that coat hook. Now the problem is I want it completely straight in the middle, so I can leave this part as is, click enter, and then create a wire from that point vertically going up using ortho up to about here. And finally I do a second part with spline, which is again I have to turn off ortho off, which is where my coat will hook on. Now you don't want sharp edges, so that's why we have this loop around. Now if this is a little uneven, you can always stretch these points like so to get the shape you're looking for. Let me see if I can do something here. Move my select lips line. So, and then if you want additional points where you can edit your design, you can go to spline, add fit kink. What is that? How you say this? Kink? I don't know. Just make sure you click enter to keep it, otherwise you lose it. Now you can stretch from there. Oops. Did I just? Yeah, I just forgot to click enter. Just kink. There we go. So now I can edit it out. Like so. So you have to come to the idea that when you do put a coat on, it won't just slide off. So actually this has to be a bit lower. Or you can readjust and change the hoop as it is. You know, actually I don't like this design whatsoever. I'm going to redo that. The more points, the easier it is to control to give you that shape you're looking for. One thing you want to take into consideration is you can't have the lines too close to each other, because that will cause the wire to overlap itself, which will not work with AutoCAD, or in real life. Alright, once you have this line completed, what you can do is design the diameter of the wire at the bottom. But to do this, you have to change your UCS so that you're looking at from Z view down X and Y, which actually what we're looking at, but from the top. We're on top. Alright, from the north. Man. So basically, what you want to do is go to north, if that is where your top is, and create a circle. Of course, the UCX didn't change. You can see the Z, which I'm not supposed to. I'm supposed to see X and Y. So you can either rotate it this way, or actually we're going to change from drafting annotation to 3D modeling, because this is when I'm going from actually designing into 2D to a 3D, so I might as well change it to 3D modeling, which takes a little time to load. Gives me my new tools, gives me my different options, including adjusting the X and Y Z coordinates if my view is conceptual or realistic. So you can see that X and Y and Z changed as I changed the view type from 2D wire to conceptual. This is where I can rotate using, of course, perpendicular to the view where I want to create that circle. The one cool thing about sweeping is it doesn't have to be actually connected to the point where you're going to sweep it. You can draw it here. Let's say the radius is, or diameter. Let's do diameter 0.2437. And you go with sweep command. You select the object you're sweeping, and then you select the path, which is going to be the small segment, and it just selects it and pulls it to that beginning point. So no matter where you draw that circle, it will self-adjust. Now the only issue here is it didn't go all the way through. The reason is this is a segmented line. There's one part here, which is a spline, regular straight edge line here, and another spline here. So what we need to do is do a p-edit. So we type in p-edit, enter, M for multiple. You select all 3 lines, or if you have more, make sure you select all of them. Convert lines to polylines, yes, click enter. Yes, keep the version at 10, and click enter to escape. And it didn't work. But they were connected. Hold on, let me pause this for a second. So what I forgot to do was use the join command in p-edit. So p-edit again, M for multiple, select the 3 lines, enter, J for join, enter, enter. Now it creates one segmented line. From there you can go back to sweep, select the circle you're sweeping, enter, select the path. Now we have a full path. And luckily it's not overcollapsing itself, so it will work and does not show an error. That's one part. Now what we want to do is array this so it has a few feet. I think we need at least 5. If you like to have more, it's fine. But to do this, we need to have a center line where we're arraying it around. So what we can do is create a center line from midpoint of our rectangle to midpoint of the top of the rectangle. So that's the center of the whole setup, which we use as a reference, which is great. If you want, you can move it in closer. If you want these wires to be closer, which may be suitable for you. And if you're in like a right view or a side view, you'll get a sense of what the spacing between the wires will be if you array it. Because we're going to use that center line as our array, and we're going to do a circular array, polar array, sometimes called a circular array. Select the array polar array, select the object you're going to array, click enter, and it's going to ask you axis of rotation. You can select that. You could create by tracing over that line that you currently have. And it's going to array based on how many items you have, the distance apart at 360 degrees. You know, there's 6 and 6, 360. One row, you don't want to do any more, and the level is just 1. So I have this new setup, and I think that looks pretty good, pretty stable. Even, you know, anywhere you have the coats, they'll hold on pretty well, which is 6 of them. And it's made out of wire, which is very inexpensive and easily made. So we have this set up. Let me zoom in there. We can remove the rectangle now. And what we're going to need to do is create additional wires that will attach, actually put these wires together. There's a few ways you can do this. I mean, we could have them welded together if they were close enough, MIG welded. Or in this case, we're going to create a wire around the top and about here at the bottom, which will help hold the parts together. And they'll probably have to be either welded on or, yeah, they'll have to be welded on, otherwise these legs will move. So they'll have to attach it here and here. Those additional wires will give it additional support. So we'll do that next as I walk around.